Hello everyone, my name is Raghunath. Today I am going to explain operating systems, system calls, compiler, interpreter, and JVM. System calls enables user programs to request voice services. Execution switches from user mode to kernel mode. They are slower than function actions due to mode switching. System calls ensure security with access control mechanisms. This ensures the security of the operating system. Each operating system has its own set of function calls and system calls, where each predefined system call performs some specific operation. For example, in Linux, for file management, we use open, read, write, close, and in Windows we use create file, read file, write file, and close handles. And each of the system calls between operating system differ between the name of the system call or the number of parameters passed into it. And to perform a particular action, we have two main types of modes known as user mode and kernel mode, with each having its own privileges. First of all, in user mode, the program will be run within the restricted access and prevent direct access with the hardware and system resources. Regular user programs applications execute this mode relying on system calls for OS interactions. It enforces memory protection and preventing programs from modifying kernel memory. Execution switches to kernel mode when privileged operations are needed to be performed or direct interaction with software is needed. And in kernel mode, we run the programs with unrestricted access. Here the program can directly interact with hardware and other resources and drivers, device controllers, and core OS functions execute in kernel mode to ensure efficient hardware management. Errors in kernel mode can lead to system crashes since there is no protection against faulty operations. Kernel mode have unrestricted actions to system memory, making security mechanisms crucial for prevent unauthorized modifications. For a given program, the program may need to execute or access some of the hardware components. To achieve this, we will make use of mode switching, in which we switch between user mode and kernel mode. The life cycle of the mode switching can be given as: initially the app requests the system call and enters into the kernel mode. The kernel mode identifies the system call, and the function of the system call will be get executed, and the return type will be written to the user mode, and again the context will be switched back to the user mode, and the app will resume execution. It is a 7-step process. Now we will be discussing about compiler and interpreter. Compilation is a 7-step process in which we have two phases known as machine dependent phase and machine independent phase, and a compiler translates high level code into machine code which specifies underlying hardware and operating system. It processes the source code in multi stages and including lexical analysis, parsing, optimization, and code generation. Compilers optimize code for better performance, reducing execution time and memory consumption based on OS specific system calls and conventions. And here in the first phase, during the first phase, the process is common for all of the compilers such as lexical analysis and parsing. But in the second phase of the compiler, we will be coming to platform dependent or OS dependent operations such as target code generation or intermediate code generation or machine code generation, in which the instructions and 3 address codes are dependent and vary upon the operating system. Hence, we cannot run in most of the cases we cannot run the source code of one compiler related to one operating system with the other. This becomes the main issue. And now for JVM, we mainly have three blocks of architecture. First one is class loader, which loads the class files into the memory and verifies the bytecode links to the execution. And runtime memory areas divides into memory area, heap, stack, PC register, and native method stack, and manages data during execution. Execution engine converts bytecode into machine code using a compiler or just-in-time compiler. Garbage collector automatically manages memory by deallocating unused objects, preventing memory leaks. Native interface allows Java programs to interact with native C or C++ code, enabling OS-specific functionality. Now, JVM enables us to clear the drawback of previous steps, which is OS platform-dependent code. In Java, the source code is directly compiled into bytecode, not the machine-specific instructions. JVM interprets the bytecode and translates into machine code for the underlying OS. Each OS has its own JVM implementation, ensuring the compatibility. JVM follows the principle of write once, run anywhere, and principle achieved because JVM abstracts the hardware and OS dependencies. JVM dynamically optimizes execution using JIT compilation, improving performance without changing the code. Thank you.